So hi everyone, happy to be here. My name is Maria Pacheco. I'm a postdoc at Microsoft Research and visiting faculty at ECU Boulder, and I'm going to present this ongoing work I have with my collaborators at Penn and Purdue on this very long title that I won't read at this point, but I'm going to jump right into what I actually want to motivate. And I'm going to talk about something a lot of machine learners don't like, which is qualitative research. But qualitative research is very important in a lot of fields, particularly in the social sciences. And making sense of really large text collections and creating code books is a standard practice that they do. And it's very important. And the idea here is that you have maybe a lot of transcripts. They could be from behavioral interviews or maybe some other outlet of textual data like news outlets. And people come into these qualitative practices with an informed what they are looking for, a research question in mind, and then they follow practices to go through this data manually and iteratively create a code book of patterns that emerge in this data that can help them address these questions and find new insights from the data. So while a lot of that still is done in a very manual qualitative way, given the boom of computational techniques, a lot of these scholars are actually looking into computational practices, and they use them pretty often. And the go-to solution is usually to plug in a topic model. So while our state-of-the-art is looking at all this sort of fancy transformer models and BERT, etc., the truth is that in these areas, most people are just using topic models. And there's a lot of reasons for that. But essentially, just to remind ourselves what a topic model looks like is usually a model in which we model each document as a mixture of topics, and we define each topic as a mixture of words. And then the goal is to estimate both at the same time. And I won't go into the details, but it's still very highly used. And one of the reasons that they know how to use it, another reason is that it's very interpretable. So they can sort of kind of look at what the output is. However, it's still it has a lot of limitations, and some of them are that they're very hard to evaluate. So essentially, it's sort of this tea leaf reading process in which people extract these topics and then try to make sense of what they mean, and then use their own informed knowledge and their own theoretical conceptual frameworks to try to make sense of what they get. And a lot of effort from the machine learning community and from the NLP community has been spent on devising these sort of automatic metrics of coherence and quality, as human judgments are very hard to obtain just from word distributions alone. However, recent work has shown that human judgments and automatic metrics do not always agree. And this is something that happens a lot when the scholars in practice is that they get a lot of essentially garbage that they can't make sense of. So one approach for this in the literature is this idea of we're putting a human in the loop, right? So if I have a human in the loop that can help me refine this model interactively, then maybe I can encode some of this information and this knowledge that these scholars bring to their practice and get better models. And this, as I said, allows experts to correct and influence outputs. But these methods also have limitations. And the main one is that given that a topic is essentially just the distribution over words, feedback is usually limited at the word level. So it doesn't really leverage a lot of the knowledge that these scholars have. So the way they usually look like is things like word constraints, in which we try to enforce that set of words appear together in a topic, or try to identify sort of representative words from experts that could identify some concept that they're looking for. But if we look at sort of both lessons from cognitive science and also lessons from conceptual and theoretical frameworks that are used in these disciplines, the human potential or the scholar potential is untapped. So by just giving feedback at the word level, we don't take advantage of our ability to formulate concepts and generalize from observations to new examples, and to deductively draw inferences via rules and statements, particularly when we're incorporating a very sort of rigid or informed theoretical framework. So this is a sort of work in progress, but our idea here is that we want to expand the notion of a topic to account for more than just word distribution. So we want to go from a word distribution to a distribution of generalized attributes and concepts that emerge from the data. For example, and I'm going to motivate you with an example. Let's say you're a communication scholar and you're trying to make sense of discussions about the COVID vaccine online. So you're coding your data and you identify something like, well, a repeating theme that I see here is that people talk about the government lying about COVID as a reason to refuse the vaccine. If we think about it, there's a lot of sort of theoretical frameworks that we can plug in here. So first of all, we can think about what this means with respect to the stance someone takes with respect to the vaccine. So how likely is it to be an anti-vaccine point of view and a pro-vaccine point of view? Or if you borrow sort of framework from the framing literature, how are certain entities being framed in the discourse? How are people talking about, let's say, Dr. Fauci, particularly when they're talking about this theme? Or even more theoretical frameworks coming from the social sciences or social psychology, like moral foundation theory. Let's say I want to ground this theme with respect of the moral foundation that is being highlighted. So when someone's talking about the government lying, they're talking about this notion of like cheating or authority and subversion. And I won't go into detail of this sort of theoretical frameworks because there's a lot to be said about them, but the idea here is that you have this sort of very flexible framework in which you move away from words and try to think about more abstract concepts that could form sort of a distribution over this theme, and it gives you a richer representation and hopefully something that experts can manipulate. So how do we propose? So we start with this sort of simple interactive framework in which we want to provide experts and also source feedback from experts at multiple levels of abstraction. So not only at the language anymore, but at these sort of higher level concepts. So the setup is we have a large collection of text. Each of is associated with a set or observed or predicted attributes. And it sort of looks like this. So we have a set of attributes that can be represented as these sort of symbolic components. And then we have experts that can give me different types of feedback. They can say, well, what does the document talk about? What is an attribute likely to take in this theme based on their informed frameworks? And then relations between different documents, particularly, whether they're talking about the same theme or not. So we experiment this very simple protocol to get started on this idea. So we have 3 human experts, 3 social scientists working together, given an initial partition of the data. And as I said, when they work on these qualitative practices, they already bring their research questions, right? So they know what they're looking for. They have some idea of what they want to find, and then they interact with the data for it. So we provide them a graphical user interface to do this, and we give them an initial partition based on, let's say, your favorite topic model or your favorite clustering algorithm. And then they start to inspect these partitions one by one. And they still follow their qualitative practices, but instead of doing it in their whole data, they're going to do it in this sort of more fine-grained partition. And then we let them name these themes that they find as they code them. And they can create 0, 1, or more per partition. And then they can give us different types of feedbacks to explain that the themes that they create. They can mark, and traditional human-in-the-loop things, mark a small set of good, bad examples. But in addition to that, we also want them to provide text that explains this theme, and also, and to go for like our main idea here, to add or correct the symbolic attributes that we present them with based on, a particular theoretical framework. And then keep following this in an iterative way in which we, once we settle on some partitions, we keep exploring the unexplored space consecutively. So why Neuro-Symbolic? So I want to motivate Neuro-Symbolic because the neural part can help us exploit the role that language plays. So, we've made a lot of progress on creating these sort of dense distributed representations of language that can be pretty powerful, both to explore the data live, right? So if I want to look for things that are similar, if I want to perform a query search or something, that gives me a lot of power. And also to sort of capture general patterns about the text. So if I'm looking again at this sort of COVID data and I have some partitions and I see, this sort of COVID fake-like arguments going on, I can use language to say something like, well, I look at a lot of wording related to being cheated, scammed, or hoaxed, and this is something that I can then, represent as a vector and then generalize across more data. And then hopefully, use that to learn better partitions. But what about the role of symbols? Right, so we say that we have these sort of theoretical frameworks that we can express in like a symbolic way, but maybe the expert can also tell me expectations about this framework. So if there's talking about COVID being fake, they can tell me that that is likely correlated to the moral foundation cheating, a particular type of framing for authority figures in which they take the cheating role, and in which the target of the cheating role is likely to be the general public. And this can be captured in this sort of weighted logic formulae, which gives me a sort of more, a way to say more with less, right? So a way to generalize across very like high level attributes in a very simple way. And then hopefully they can also help me partition the data better. So just to, I don't know how short I am on time, but just to give you an overview of how we could actually model this, we can model themes and relevant attributes as distinct variables that can, as I said, learn through human interactions. But we replace topic modeling with inference. So we have many decisions that should sort of coexist with each other. So, and weights for these rules that I show would capture these dependencies between these different decisions here, let's say the supporting conceptual framework and the emerging themes, can be learned then using expressive encoders that take advantage of the text. So it looks like a standard graphical model in the sense that you have sort of interdependent decisions, with some weight that gives you the likelihood of that strength of the relation, but then you can use your favorite encoder to learn those weights. And we use it using our a framework we developed a few years ago called Derail, in which you have this sort of general declarative framework to express symbolic rules and associate parts of that rule with expressive representations. I won't go into details about Derail, but if anyone's interested, I'd be happy to talk about it offline. But this is what we represent in this case, right? So we have first order factors that just encode the likelihood of the text to be assigned to a particular attribute or a particular theme, and then dependencies between them, right? So given attribute A, how likely do I have attribute B, or given attribute A, how likely do I have an emerging theme? And then some constraints over this can also be expressed. Then we can represent this as a graphical model, and I sort of will skip through this and just talk a bit about the case studies. So we looked at 2 case studies on sort of analyzing this course. We have the COVID-19 vaccine debate, which has been my running example. So we have about 100,000 tweets about the vaccine, and we have some theoretical framework that we want to ground it on, in which we have stance, moral foundation, moral framing, and entity roles. For the more information about that, you can look at our previous paper at NACO. And then we build also on the immigration debate, in which we have about 3 million tweets about immigrations. And here we have very distinct or different theoretical frameworks that we want to use, but I want to show that we can use the same sort of representation framework to model both of them. So here we have other types of framing typologies, like narrative frames, generic policy frame, and immigration-specific frames. I don't have time to go into the details, but in the end, you can think that all of that can be represented using the same type of rules. So we did some initial experiments in which we looked at consecutive in rounds of interactions with the experts, and we look at both the coverage, so how many tweets we can account for after uncovering the themes interactively, and then also how good we are at doing that. Just to think about, we first compared our system to traditional topic models in which there's no interaction at all. And then we compare our neuro-symbolic grounding procedure with a procedure that just takes all the symbolic out of it and just looks at the distances between the embedding space. And our hypothesis about, what is good. So evaluating these type of things is really hard because there's no ground truth, right? You're essentially creating the code book. So we have this hypothesis that themes can be characterized by their relationship to higher level attributes and concepts. And this is the way in which, qualitative research is done. You ground it in some theoretical framework. So they're going to be better if they're more cohesive. Essentially, how is your variation within a theme with respect to all of these other dimensions that you're analyzing, like stance or morality frames or etc. So we sort of adapt the notion of a cluster purity to account for this sort of attribute or conceptual purity. And then we find that, unsurprisingly, right, if you encode this information into the inference, you get pure, conceptually pure partitions than you do with a traditional topic model. And also we looked at actually having some human judgments to see whether the output made sense. And it's really easy now to have humans judge that because they name their own themes, right? So the theme's gonna have a name, it's gonna have all of this information associated with it, so it's very expressive. It's not like this distribution of words of a topic model in which it's really hard to evaluate what it looks like. And that's the reason the topic model doesn't have an approximate F1, because we couldn't find a direct way to test that. So to summarize, we proposed a new definition of topic or theme, defined both over the language over generalized attributes or conceptual frameworks. And we proposed a simple interactive protocol to receive feedback at multiple levels of abstraction, both the text and the symbols. And we introduced the Neuro-Symbolic mapping procedure to introduce this feedback into the system. And we find that our themes are more interpretable and easier to evaluate than topic models and accurate with respect to human judgments. And now we're working on expanding this evaluation with a sort of in-depth qualitative analysis just to show how this compares to your traditional topic models. But thank you so much, and I'm happy to take any questions.
Oh, wait, no questions.